two major steps to this problem before we can get started. First thing you have to do is understand what this first sentence up here is saying. Okay, read it carefully for a moment. My version, anyway, which might be different from your version. My version says A, B, and C are distinct real numbers. That means they're different from each other. They don't equal each other. And A times B times C is not equal to 0. Now, if their product is not equal to 0, here's what my clue is basically saying. My clue is saying that means A is not equal to 0, B is not equal to 0, and C is not equal to 0. If any of them were equal to 0, then their product would be 0. Okay, so that's clue number 1. They're non-zero numbers. Clue number 2, we have to get from rearranging these equations. And I'm going to just talk about the first one right here. I'm going to show you how I rearrange this, and then you can do something similar for yours. Okay, so bx equals c minus ay. I'm going to add ay to each side. I'm going to subtract bx from each side. I get this. It's the same thing. I just rearranged it a little bit. And then I rearrange it a little more by dividing each side by a. And I do that so that I can have slope-intercept form. Okay, this equation right here at the bottom is the equivalent of that top equation. So let me put this up here, and I want to now write the second equation below it. Okay, I'll skip a few steps in this one. Holy cow, something went wonky. This is supposed to be a b. There we go. So now the second equation below it is going to be similar but not quite the same. You get y equals, if you go through the algebra, y equals b over a x plus c over a. So you can see these two equations are similar in some ways, but there is a key difference in that plus or minus sign. And now I'm going to start talking about all the values in this table right here. Slope, x-intercept, and y-intercept. So let's figure out what these things are. For the first equation, the slope is just the thing in front of x. That's going to be negative b over a. For the second equation, it's going to be positive b over a. The x-intercepts we find by setting y equal to 0. So if I set y equal to 0 on the first one, I get this. 0 equals negative b over a, x plus c over a. I multiply both sides by a, and I get 0 equals negative b, x plus c. I add c divided by negative b, I get this. X equals c over b. Okay, that's the x-intercept from the first one, which I got by setting y equal to 0. Okay, so that's c over b. If I do the same procedure for the second one, which I'll skip for now, it would be negative c over b. All right. Now for the third one, the y value of the y-intercept, what you do here is you set x equal to 0, and that gives you the y-intercept. So if I do that for the first equation, let me make some room here again. First equation, I set x equal to 0, I get this. Y equals c over a. That is the y-intercept. This one's a little easier to see. C over a. The y-intercept of the second equation, when I set x equal to 0, it's the same exact thing. It's again c over a. So now we have all the clues we need. If you look at this table, these are all the actual entries for my version of this problem. Yours might be different if a, b, or c were 0. See, if a were 0, for example, that would become a DNE instead of some fraction. So you got to be careful about how you enter those, whether it's 0 or DNE. You want to say that. Now, what we have to do at this point is say, okay, compare these two lines to each other. What's the same and what's different? Well, clearly, they have the same y-intercept, but they have different slopes. Probably spelled different wrong. That's fine. Math teacher here. They have different slopes and x-intercepts. So try to picture the graph that we're talking about. They have the same y-intercept, but different slopes and different x-intercepts. So maybe we're talking about something like this, where that's one line, and that's the other line. Okay, I drew the same y-intercept, different slopes, different x-intercepts. What you see here are two lines which are distinct and are intersecting. Okay, so this is the procedure you should go through regardless of your type of problem. Fill out, first, use your clues to rewrite the equations as much as you can. Then fill out the table, then graph it, and make some description of your two lines.